Okay, picture this. Imagine a massive, glowing 3D network just floating right in front of you. What if we could take, well, literally everything? People, products, companies, documents, global events, connect them all in that space, and then use those connections to find hidden relationships we had no idea even existed. I know, it sounds totally like science fiction, right? But honestly, this is happening right now with the data all around us.
Welcome to this explainer. Today, we're going to unpack exactly how modern data networks actually build these incredible living connections. We're looking at the definition, the structure, and exactly how graph engineering works behind the scenes to make sense of our super complex world. It's going to be a fun one.
Okay, let's dive into this. We're going to start with the power of connection. Check out a really cool online shopping graph, and then walk through the 6 steps to building graph data. After that, we'll scale it up to real-world supply chains, see how graphs are powering modern AI, and then we'll wrap it all up with a quick summary of how things connect. Let's go.
Section 1. The power of connection, moving beyond rows and columns. To really wrap our heads around graph engineering, we kind of have to rethink how we look at information in the first place. Think about a traditional database. It basically stores facts in separate tables, right? Just rows and columns. It might tell us that Rahul is in one table and ABC Company is in completely another. But graph engineering flips that on its head. It represents those facts as connected entities, focusing heavily on how that information is actually linked together.
So to build this epic cinematic network, every graph starts with 2 basic building blocks. The first one is a node. Just picture a node as this glowing sphere in our 3D space. It basically represents an entity or an object. You know, it could be a person, like Rahul, a company, like ABC Company, a location, like Mumbai, or even a piece of software, like SAP. Basically, any tangible thing in our dataset, boom, that becomes a node. Now, the second absolutely critical component is the edge. If those nodes are the glowing spheres, edges are the laser-like lines connecting them together. An edge represents the specific relationship between 2 nodes. For example, think about the action works for. That's the edge that links Rahul directly to ABC Company. Without edges, well, nodes are really just isolated dots floating in the dark. So, if we take a step back for a second, the core philosophy here is just incredibly elegant. Nodes plus relationships equals a graph. That's it. This simple, beautiful equation is the foundation of everything we're about to explore today, and it unlocks capabilities that those flat old spreadsheets could literally never even dream of. Section 2. The online shopping graph, a simple e-commerce example. Okay, to really see how nodes and edges create value in the real world, let's imagine a standard online shopping website. First, we've got our customer nodes, Rahul, Priya, and Amit. Then we've got our product nodes, a laptop, a smartphone, and a headphone. Now here's where the magic happens. Let's add our relationship edges. Rahul purchased a laptop, Priya purchased that exact same laptop, but she also purchased a headphone. Amit, meanwhile, just purchased a smartphone. And just like that, we've built a connected graph. And you know what? This perfectly illustrates the hidden pathways that graphs uncover. Think about the flow here. Rahul points to the laptop, but Priya also points to that laptop, and she points to the headphone. So, through that single laptop node, a structural bridge has just been formed between Rahul and Priya's shopping habits. They're connected. Now, put yourself in the shoes of that e-commerce system for a second. Based on this very specific network of connections we just built, what should the system recommend to Rahul next? I want you to take a quick second and think about how you would solve this puzzle using those exact pathways. Well, if you guessed the headphone, you hit the nail on the head. You see, because Priya bought the exact same laptop as Rahul, and she also bought a headphone, the graph instantly identifies that shared behavior. Guys, this is the exact underlying architecture that powers those customers who bought this also bought features on all the world's biggest e-commerce platforms. It instantly generates these hyper-intelligent recommendations simply by walking the edges of the graph. Section 3. 6 steps to graph data. The graph engineering process. All right, let's step into the engine room for a minute and see how we actually build this thing. What's really fascinating here is how we take completely raw, scattered data and turn it into a powerhouse insight engine. So step 1, we collect data from places like ERPs, CRMs, or IoT devices. Step 2, we identify our entities. Those are our nodes, right? Like the customers or the products. Step 3, we map out the relationships, our edges, like purchases or supplies. Step 4, we physically build the graph using specialized platforms, things like Neo4j or Amazon Neptune. Step 5, we query the graph, which basically means we traverse those relationships to ask some really complex questions. And finally, step 6, we generate the insights, which powers everything from advanced search features all the way up to AI.
Section 4. Real-world supply chains. Tracking disruptions.
Now, let's take this concept and apply it on a massive global scale. Picture a super complex global manufacturing process. Supplier A supplies component X. Component X is then used in product P. Product P is manufactured over at a factory in Mumbai. And that Mumbai factory directly serves customer A. It's this delicate, continuous chain that literally stretches all the way across the globe. But here's the billion-dollar question. What happens if supplier A suddenly experiences a massive disruption? We're talking a factory fire, a crazy storm, a sudden material shortage. In this gigantic global network, how on earth do you know exactly who is going to be impacted at the very end of the line? Well, so here is the crucial point. A traditional database, that would take hours, maybe even days of joining hundreds and hundreds of tables together just to figure this out. But a graph database, it traverses that entire chain instantly. It just follows those glowing edges right from supplier A, straight through the component, the product, the factory, and boom, it flags customer A immediately. It gives businesses this incredible, real-time visibility into cascading failures. It's a total game changer.
Section 5, Graphs in Modern AI, Enhancing Intelligence.
And because it gives technology the ability to genuinely understand context, graph engineering is actually fueling modern AI. When you combine AI systems with graph data, something pretty magical happens. Look, large language models are fantastic at reading text, right? But when you feed a structured graph into an AI, which is often called a knowledge graph or a graph RAG architecture, the AI actually begins to understand how entities relate to one another in the real world. It gives the AI this incredibly deep, factual context. And because of that deep context, graph engineering is literally working behind the scenes in almost every single digital service you use today. It's powering those spot-on recommendation systems on Netflix and Amazon. It's completely revolutionizing fraud detection because it can instantly spot super suspicious connections between devices and random transactions. It's structuring knowledge graphs for way smarter search engines. It's ensuring supply chain visibility. And it's providing that crucial structured logic that keeps generative AI systems accurate and totally grounded.
Section 6, Summary. How things connect. The 1-minute recap. Okay, let's wrap this up with a quick overview. Ultimately, graph engineering is the process of building systems where data is represented as entities, which, remember, we call nodes, and relationships, which we call edges. Together, they form this vast, interconnected 3D map of information. And by traversing these edges, we completely move past simple data storage. We unlock the ability to answer highly complex questions, detect fraud in real time, and finally give our AI systems some true logical context.
Ultimately, I want to leave you with this one defining thought. Traditional data tells us what exists, but graph engineering helps us understand how things are actually connected. So, I want you to think about your own data, your own business, or honestly, even your own life. What hidden connections are just waiting to be discovered once you finally start looking at the edges instead of just focusing on the nodes? Keep exploring, and I'll catch you in the next explainer.